Hi, Chem Team. We've learned that the valence shells around atoms can become more stable by gaining or losing electrons. Well, it turns out that the nuclei of atoms can become more stable through a process called radioactive decay, in which they emit particles called radiation. Now, there's three main types of radiation. The first type of radiation is called alpha radiation, in which an unstable nucleus will lose an alpha particle. And an alpha particle is just two neutrons and two protons, which is the same thing as the nucleus of a helium atom. The four particles would have an atomic mass of 4 AMU, and the two protons would give an alpha particle an atomic number of 2. Meanwhile, since there's no electrons, the charge would be positive 2. So an example of alpha radiation would occur with something like plutonium-240, which is a very unstable isotope of plutonium. And during alpha radiation, the plutonium will split apart. It will break off an alpha particle from its nucleus. And what's left over is a smaller nucleus. It has lost 2 protons, so it is no longer plutonium, it's now uranium. And it lost 4 atomic mass units total, so its mass is no longer 240 AMU, it's 236 AMU. Another type of radiation is beta radiation, which occurs when a neutron in an unstable nucleus changes into a proton and releases a beta particle. Now, a beta particle is just an electron, which can be represented as a lowercase e with a negative charge. But it doesn't have any mass or any atomic number. So an example of beta radiation would occur with something like carbon-14, which again is an unstable isotope of carbon. And to become stable, one of the neutrons in carbon's nucleus will change into a proton. We'll watch that happen here. And in this process, you can see that a beta particle, or an electron, was released. Meanwhile, the atom that's left over is no longer carbon. Because one of the neutrons changed into a proton, its atomic number went up, and it's now a nitrogen atom instead of carbon. And the last type of radiation is called gamma radiation, which occurs when an unstable nucleus releases a gamma ray, or a gamma particle. Okay. And a gamma particle, or often called a photon, is just a very high energy ray, which here is represented by this high frequency wave. But it has no mass to it, and so it has very high penetration power. It's able to sink deeply into objects and living things. So an example of gamma radiation can occur with plutonium-240, which again is a very unstable isotope of plutonium. And during gamma radiation, to stabilize, the plutonium will release a gamma ray. However, because the gamma ray has no mass to it, the plutonium nuclei is completely unchanged. There is no change to its mass or to its atomic number. And that's it. At this point, you guys have a couple of practice problems. We'll see you in class tomorrow.